She specializes in the intersection of mathematical models and socioeconomic systems, and her innovative research delves into understanding complex adaptive systems across various scales, from biological entities to large-scale urban and technological environments. Her work takes a very interdisciplinary approach and employs computational social science to explore the dynamics of innovation, the intricacies of urban development, and the evolution of language, and aims to uncover the underlying mechanisms that drive economic diversity, specialization, and the future of work. She also grew up in Korea and was educated at the National University there, and is one of the rare people who holds an appointment at the Santa Fe Institute, NICO's competitor.
So I would say collaborators.
Collaborator, better phrasing. So everyone, please help me give a warm welcome to Hyejin as she talks today about labor ecosystems. Thank you, Hyejin.
Thank you very much. Thank you very much, Tara. Thanks very much for coming for this talk. And yes, it sounds like Tara just describe what I've been doing. And then I was just listening to what I've been doing. Sounds like I've been doing a lot of different things. So today I'm going to talk about maybe like encompassing what I've been doing to understand why system becomes or these days, like we become more complex societies. And what does that mean? What's the implications for our individual developments and career developments? So I start with these questions about, let me just see whether this increasing complexity. Now I start with this photograph. What do you think about this stone? What is this? Weapon, okay. Anyone else? What's that? Yeah, it's a. Oh, let me see whether I have a clicker. I don't. So this is supposedly, like there has been a lot of contestant and debates about this first tool. So this is the supposed to be first tool. It's a tools like hand axes. In a long time ago, our ancestors and hunt and gather and then grind things and sharpening things, chopping wood with this like cutting meat. So this was very simple tool. Now, what do we have now? This is the first iPhone. It's a smartphone. It becomes so complicated. What has happened between tool that I can produce and anyone can produce from the outside and very simple all the way to this complex device? What is the consequences for us? So that means we have to learn a lot. It's beyond the grinding a stone and finding stone and grinding stone and find a good purpose of this stone. It's actually, we have to learn a lot of things and we have to, not the same materials we have to learn, and we have to learn different things and specialize in a certain way to be useful into our society to make us this complicated device and tools. So first figure shows these figures are coming from the Ben Jones, our colleague at Kellogg, who was looking at the first inventors, the age of inventors' age that when we produce the first patent. Or maybe you can just, the ages at which you have the first publication of your papers. Age is going up. Meaning that to be useful, you have to learn more. And it takes longer time to get to that point to be productive. Second figure is about the probability of jumping from one field to another. It becomes much harder to go from one specialized field to another field. Third is about the collaboration size. Do we need more people to produce a patent or papers? Now, it actually comes down to questions about the complexity increasing, how to cope with this increasing complexity as individually and collectively. We specialize in different fields. We collaborate to produce something together. It takes the time and efforts to get to coordinate together. So first, there is so much we can learn, meaning that we have to learn a lot to produce iPhone, but our time is limited. our cognitive capacity is limited. So we have to actually take a bits of the parts of the iPhone, the production processes, and come together, and specialization working together come together and become a complex global network structure, industrial structure, and education structure, and the knowledge structure all come together. And this is our study. So come back to this question, first stone tool to first phone, iPhone. I started with the questions like, can I make this tool, individual tool? Yes, I can. I go out and maybe maybe not as sophisticated as this, but we could find the tool, find the stone and grind it in a certain way to make this stone, this tool. But if I want to make an iPhone, I don't think I can. Maybe some people can, maybe some people cannot. So I can ask myself, what if I want to make this iPhone alone? So I actually went to Google and find a way to make your own cell phone from scratch. And I read through and what the processes are needed. It's actually really, you could imagine, I mean, this is not surprising. It's just like really lengthy steps and processes. And even, I mean, so it was actually very helpful, to understand how complicated this small device that works with you every day. It's just so intense, complex, and knowledge and technology come together in this small device. And then even then, going through this process, I also I realized that I think this is behind. You have to order a few devices. Even then, it's not that you make the iPhone yourself or cell phone yourself from the scratch. It's not really from the scratch. It's from the scratch, but by you mean it's like you have to start with the sand to make a silicone, and also even the fire, making a fire. Can you make a fire yourself without any matches? And it's extremely hard. Somehow we make infrastructure and industries and knowledge embedded in our society in a way to become so productive together. Things that now we can produce things that we cannot produce by ourselves. So what would you imagine? I mean, this is, I was playing with a ChatGPT to create the image. This is kind of things that, nowadays, any kind of devices, like even the water bottle and even this simple pencil has to go through all the processes, complicated process. And we have so many devices and the tools and the products and services to very complex and to be productive together. Now, what's the consequences? We talked about some of the evidences, the consequential evidences that we have to learn a lot and it becomes longer to be productive. So the first paper will come out later age than past. And that actually has this come together, this notion of increasing complexity, puts a lot of pressures on individuals, becomes so specialized with a diverse, but together, it is very diverse portfolio to produce something complex. As a result, we also see that firms and occupation increases, number of firms and occupation increases, and we become more efficient and productive. So it's a number of occupation over time increasing, and the lawyers, because it's a more specialized and come together, specialized people come together to be coordinated and work together. The number of different lawsuits and conflicts increases over time, of course, and the governance expenditures and administrative expenditures increase over time as a result of specialization. So there is some kind of overall overarching mechanisms, underlying mechanism come together to understand increasing complexity and the implication for individuals' life. So come back to this question now. I want to there are so many ways to go about this understanding increasing economic complexity in the society. But let me just focus on the individual people at the moment, laborers. So again, this stone tool, I can produce this stone tool. But if I bring my my colleagues together and divide the process of this creating tool to be small pieces, and we are doing the repetitive things like the small tasks to come together. It will be more productive. What do I mean by this? If I bring Danny to join my team, then Danny, can you find the stones, like appropriate size of stones? And in the meantime, when Danny finds the stones, and then I just grind it. I don't need to find the stone, I just grind it. Then we are specialized in a division of labor takes place. We specialize, and it becomes much productive. And then maybe like I bring Edlison asking that, can you just cut it? And then I'm going to just grinding it and cut it, grinding. And we also divide our labors. And because we are just focusing our own stuff on the simple tasks. So there is the things that we are learning by doing. We repeat certain behavior, then we find this optimized way of perform, and then it becomes much productive to produce this even the small tool. So division of labor took place in the past too. But here, this is not only just division of labor to increase the productivity, but also division of knowledge. I can't really know every single bit of the processes. So I can't really produce the smartphone myself. And also I have, it will be much easier if I just divide the labors, not only labors, but also knowledge. So now, again, come back to this question. So specialization. So it seems like a specialization is not just one simple mechanism we thought about. There are two different pathways of specialization. I realized from this simple example of stone tool and the smartphone. So on one hand, the conventional way of understanding division of labor is this conveyor belt, stone tool. So we divide our labors and tasks and processes, and we just focus on the simple tasks so that we increase learning by doing mechanism to increase our efficiency and productions. And also, there's a sort of side effect for this. It's not just increasing our productivity, but also we decrease our bargaining power, meaning that labor becomes cheaper. So for example, if the task is so simple, it can be replaceable. If things are replaceable, I can hire anyone. I don't need to obsess with Danny. I can ask him, oh, can you just do this? So it becomes cheaper. This is what I mean by bargaining power, and it decreases. So all these processes like Marxian view kind of thing. So I'm not going to detail, but on the other hand, there is another process of division of labor in terms of division of knowledge that goes slightly the other way around. So if looking at this, the knowledge becomes knowledge that are embedded in the tools and technology becomes so much that no individual can bear. So we divide the knowledge, and I asked, can you just take care of the optimization process? I just look at the functions, certain functions on the program. Mo takes care of a certain function. I take care of a certain function in my program and come together. So it's like division of labor and profession seems to go different paths of mechanism than the conventional way of understanding of division of labor. So that actually increase in bargaining power becomes it's a more of unique skills, unique knowledge. So now the question is, what does that mean? So why? And why one it becomes more valuable, one becomes less? Maybe I try to answer this question from the structural perspective rather than introspective, qualitative understanding of the world. So I just think about this, that maybe there is some long training of the learning or long trajectory of learning that goes through certain steps that make the barrier to access certain knowledge immediately. So for example, if I want to become quantum mechanics, want to understand quantum mechanics, it's better for me to understand calculus, and the calculus without understanding arithmetic is hard. So there is some kind of a learning process and knowledge that only can be accessed. There are some knowledge that cannot be accessible immediately. You have to go through the processes. And these processes actually make a barrier, and sometimes a barrier, and sometimes a streamline or the promotion to access certain job sequences. So it's basically idea of the specialization in professions. So there are some professions that are specialized in a certain knowledge that becomes not replaceable, easily replaceable. There are professions you are specialized, but it's easily replaceable. Now, how do I want to understand this? So I have this hypothetical structure in my mind. So think about this. So suppose there are skills that are prerequisite for many different skills. For example, this is quantum mechanics, and this is general relativity. Only through understanding, once you understand the calculus, and the calculus has to be has a prerequisite of the arithmetics, and then there is some different branches of this from this general skills, the code like programming, and so there must be some kind of branches from generating or branching out from the general skills. So there must be some general skills. There must be some specialized skills branching out from the general skills. There must be some skills that may not be dependent on anything else. So from there, I would like to understand whether that can be found in our, I don't know, like accessible, like a publicly accessible data sets, so empirically observed. So here, so I look at this. We could potentially look at the skill sets, skill dependencies from the curriculum in university, but that doesn't include these skills that are used in working on the job. So I would like to just see how these jobs actually reveal this skill dependency. So for example, here, the job number 1, if you are general relativity researchers, and maybe you have these skills are required. If you are programmers, these are the skills that are required by programmers. So, by the way, gray area is kind of a jobs. Is a job that requires those skills, and some jobs may not require this. So from this hypothesis, I could make a prediction that if I look at what skills are required, how many occupations and jobs, general skills should shape this kind of a broad distribution, as opposed to specialized skills that are more focused on the more skewed distribution. So there is meaning that there are only few jobs. This is just a number of different jobs, occupations. There are only few jobs that requires this specific skills at the high level, as opposed to these general skills that are like broadly distributed, meaning that any jobs, like the frequency of job, any job may need like this skills at the medium level, because they are general. You need like arithmetics anyway. So these are like hypotheses, schematics, empirics. So I look at the survey data, occupation data in the United States. And ONET is a survey data. Basically, like the people come to your job and asking that what kind of skills are needed, and they check the boxes. And they have this the comprehensive table, information table, saying that occupation code and occupation title, and what are the skills that are required this title at what level and what importance. Usually, importance levels go together. So we did a lot of the robustness checks, and it didn't matter that much in the end. So for example, here, let's see, CEO, chief executive, requires high level of personnel and human resources, and the management and financial resources level. If I look at the pilot, it doesn't have much of, hold on, let's see, chiropractors, doesn't need a technology design, but requires a lot of, It requires a lot of active listening. So you have this like list of things. Yes, sir.
Can you
tell me how skill level is defined. I missed it.
Yes. So I ask you, what kind of these are the list of the skills and knowledges I provide you, and ask you, could you just check the level, put the levels each skill needed in your job? Yeah.
It's a scale from.
From 0 to 7.
Oh.
Yes.
And so they're just asked.
Yes.
Is it the same with importance also?
1 to 5 or something. So there is some ranges, but we like it doesn't really matter at the end of the day, because it's just distribution shape we are looking at. But yes.
I'm going to ask a really annoying question.
Oh, yes,
I apologize.
of course.
So it's really interesting. If I understand correctly, you use ChatGPT to generate an image in the beginning, right?
Yes.
Right. So it's something that actually many of us feel many times, that it would be great to have the ability to do nice visualizations of stuff. But if you actually ask, how important is fine arts knowledge to be a faculty, you would say, I don't need it at all, right? So there is a way in which it's not really what you need to do the job in a certain way, is what somehow it has been accepted that you need.
You mean that the edge, some additional advantage if you have that?
No, it is that almost actively you don't, and this is another thing. I don't. Well, you are much younger than me, but maybe some of the other people remember this. If there used to be some faculty in physics that if you had nice looking slides, they would look down on you. It's kind of,
if you also there is
why are you doing this? Slides should look like shit.
Well, then
That's the way that, right? I mean, it's like that you are trying too hard, right? So there is given a kind of negative if you are actually trying to do something differently. And I would say, for instance, just to give you another example of how these kinds of things are weird. Back pain is one of the most significant problems affecting lots and lots of people. And you could say that we all suffer from back pain because we don't learn how to move or how to sit or how to take care of our bodies. You would imagine that this would be an incredible skill. We just have decided that we are not going to teach it, right? We are not going to have qualified teachers in school teaching you how to move and how to take care of your body. You have some idiot teaching physical education in which they don't teach you anything, right? So there is sort of a history and a tradition about what you expect, how much you want to develop certain things. And so the reason why my question is annoying, was there a question? Is to what extent are you thinking about how are these sort of historical accidents that has gone this way versus it has to be this way, right?
That the current analysis and finding do not actually answer your question, but I've been so much interested in that question, historical contingency and socially constructed, and we've been discussing, like actually one of paper with Solomon over there, the new postdoc, and NICO, welcome, and we try to ask this question: what is adjacent possible space of possibilities, and does this space of the kind of sidetrack space of possibility give you some idea of why some states are we discussed it pre-statable, and some states are not pre-statable. And some states we come together is a pre-statable in a more like a physical world, but some states are not pre-statable. It's just develop over time, and it's not ergodic in the sense that we can't really come back. It's just once they're there because it's just so numerous, and there is no way we can realize all the spaces. So there are so much interesting things we are actually discussing. We'd like to come back to later, but and then that actually comes to the point of the contact here is that the way we actually construct our professions, maybe coming from these contingencies. But it is kind of interesting. It's not just entirely contingency. It is actually, there are things like gravity. If I just talk about the contingency, someone would say, oh, jump out of the window, then you see whether there is no law or something. There is a gravity, there is a law, there is something that will happen no matter what. But there are so much spaces that are actually created from equally in nothing. So the professions and the kind of the knowledge and we value sometimes come from nature, may come from the way the society has created. And that's actually a really interesting question. The letter is not answered that well here. So okay, so coming back to stick to the simple analysis here. So as it is from this data set, we have thousands of occupations. We have hundreds of different skills and abilities come together and items, and see the distributions. And some, as we just discussed earlier, some skills are not needed by most of occupations, but only just few occupations, high level. Some skills are broadly required, but not at the best at the highest sense. So now with that, we can actually create all this distribution and cluster them accordingly. So general skills and specialized skills. And the color coded from now on, you just have to remember is that red means it's just general skills. Blue means it's specialized skills, meaning that it's skewed distribution. Only few occupations have those, requires those skills. Only few occupations require those skills at the high level. Most of occupations don't need those kind of skills. Now with this distribution, we cluster them, and these are signature of the profile of each occupation category, general to the specific. Now come back to the hypothetical structure we construct in the beginning of this talk is this. So we have general skills, because occupations are going to specialization trees, the branches. So I would imagine that the general skills will appear probably broadly and appear a lot of broadly across different occupations. And there are specialized skills that only appears a few jobs. Now with that, we can ask this question. So okay, we saw the distribution. Now we ask this question: how does branches look like, and whether these branches are not connected and disconnected and skewed or not skewed? Let's construct this. So because we know this, some skills appear broadly ubiquitous and some skills are specialized, meaning that some skills are maybe contingent on the other skills. So we use the conditional probability here. So the probability of having A conditional on B may not be the same as probability of B of having A, meaning that they are not, if A and B, the skill A and B are not independent, they are interdependent, maybe some skills are contingent upon other skills more than the other way around. So let's just take a look at the example. Math skills and programming. We look at the occupations that require the math skills. Again, math skills are more broader skills than the programming skills. So the skills that these skills are required by many different occupations, as opposed to program skills only few, and they are subset. If this is subset, what does that mean? Meaning that if I find occupation that has a program skills, chances that this occupation also requires a high level of math skill higher. Now I can create this asymmetric the link like this by calculating P of A conditional on B, or P of B conditional on A, and the different. If the first is larger, then I consider this the direction. Let's just consider another one. Maybe not everything has this clear direction. Maybe some things are not clear direction. Maybe there is no direction at all, and there is no shared. For example, repairing skill, because they are independent. The independent event is conditional probability is a joint probability because it just multiplied between independent events. So in that case, they are separated mostly, and their probability, conditional probability between A and B and A on B and B on A is equally likely. So there's no link or no direction. So I can actually see whether there is another pair. We can also see other pair. Critical thinking It's also very general skill that is required across many different occupations. And they have this clear, the direction we can calculate. Now, adding all these pairs, another example, oral expressions and negotiation. Adding all these pairs results in the hierarchical and nested structures, nested skills. This is the final result. We look at like all these the skills that are general skills on top because we use a different like local reaching centrality to make a visualization. Local reaching centrality means if you just if you go from one node to how many other nodes reachable through this directionality, these are highest reachable nodes, and these are lowest reachable nodes, and we create them with allocation access. And you can see that some of them are very much dependent on the others, and these are not dependent. So we consider them, these pathways are nested specialized pathways. These are unnested specialized pathways. And now we started to use the term nested and unnested. Now, one would ask the question, what do you mean by nested or nested? And on one hand, this is like nested in a sense that they are under, these skills are under these general skills, as opposed these skills are not under these general skills in terms of this directionality and the local reaching centrality. Now, the question is, okay, is it two questions? One is, was the initial constructor is rightly embedded in all the aggregated network? Second question is, what do we mean by nested, unnested? Can you categorize the skills into two parts, nested and unnested? So let's go one by one. First, remember these are the small constructs and see whether the math skills and program skills are dependent. Here, program skill, math skill here. And also, and math skills and the program skills are far away from repairing and the dynamic flexibility, as you see from the initial constructs. And as I alluded in the beginning of this visualization, these are not highly dependent. We call it nested specialized paths. These are shallow dependent. And those skills are repairing, dynamic flexibility, mechanical, and the finger dexterity, and the things that are manual, more related to the physical skills that can be trained from these repetitions and routinized tasks. And then these are the jobs I can see. So these are our theoretical construct. Now the question is, I want to separate the nested and unnested from there. I want to see what does the nested structural property actually mean in our society. What I mean by mean here is meaningful meanings or rewording, like wage premium and the ages and genders. We want to actually now quantify them after this visualization. So we use this term, the ecological structural property, which is called nested unnested. Nested unnested is following. I use this method from the Uzi's, our co-director here, paper, saying that here you have bees or butterflies and you have plants, and some bees and butterflies that go to the plants. Every different plants like this, some bees and butterflies don't go to the plants. Every plant is specialized. In the ecological system, there is a notion of the specialist and non-specialist in species. This notion has been used in very different systems like country and products. So some countries like United States produce everything. Some countries don't produce everything on few productions. And these actually has reversed things that some products can be produced by everyone, but some products not. So let's just use it in our skill and occupation occurrences here. So on the one hand, the skills, and on the other hand, the occupations. And there are occupations that require every single skills. There are occupations that requires only small skills. There must be some nested structures from which we can infer, or we can drive the expected distribution that we already observed in the previous slides. So here, the general skills, these must be general skills, these must be specialized skills. Now, the question here asking is that, okay, this sounds reasonable. The next question is, what are the skills that are contributing to this nested structure? So what if the skills are not really contributing the nested structure? Because like if some skills appears really randomly, they are not actually attributed to the nested structure as a whole, the skill S here. So what we can actually do is that we measure each individual skill's contribution to nested structure. How do we do that? We measure the nested structure, like how the upper triangle, how your skills occurrences look like upper triangle in this metric, and how much randomized skill, each skill, deviates from the observed upper triangle, the ideal upper triangle appearances, the nested score. So nested structure again means it's an upper triangle, how close your matrix to the upper triangle, expected upper triangle here. And whatever happens in the randomized one, it's going to deviate here unless you start from here. Does that make sense? Okay, so we randomize this, so the bootstrap, and see whether each skill is contributing to what's the level of this, each skill contribute to the nested structure, and we categorize each skill accordingly. So here's the example. Each node indicates skill. And you can see again, the red are general skills, blue are specialized skills. And then we can make the data mark empty when we find the skills contribution to the nested structure is negative. So those skills are actually destroying nested structure, the empty data marks. And then we see how they are related with wages and automation risks. So there is an automation risk in the literature. We just see how this nested, the structural property indicates some socioeconomic properties. So we see that there is a clear distinctions here, like empty is negative, the contributions, positive, the skills that are contributing positive, skills contributing negative. You see that the wages is up or higher, less here. So there is something structural property actually plays out in our socioeconomic mechanism. And these are the list of the skills that belong to our categories. Now, the second question would be asked, okay, does it actually mean our career progress or not? Because so far we just look at the co-occurrences across different occupations. So we actually look at the 3 different data sets. One is the BLS statistics, looking at what's the average age for each occupation. And we bucket each occupation, we slice the occupation by their by age bracket, and see what's the level of skills into each category look like. So first row. And you can see that as the occupations you will have at the age of 40 will require a higher level of nested skills than the occupation, the later part. Sounds about right. And the second, the first one is actually not individually connected. We just measure the ages, average ages of each occupation. Now we look at just actually the survey data, current population survey data that ask you individual household, asking what kind of jobs you have, and then we map them, then skill sets, and these are the data set that the respondents at the age of 20. And then we look at what's the job is changed, and they changed jobs that require the higher level of general skills up. until the age of 40, and after which that doesn't really increase that much. It was very interesting that the gender disparity here, the males increase up to the age of 40 to 15, while the female actually stopped the increase around the age of 30, where the child born was to start to happen. We have additional analysis to see what's the impact of the child born in the household. In this current population survey, it sounds like a really impact, having huge impact, especially on the nested specializations process. Now, the third data analysis, we include resume. We have like hundreds of millions of resumes, and in each resume we have a job sequences. And through these job sequences, we analyze the skills required for each job sequence from the first job all the way 7+. And it was very interesting that the increase actually happens at the fifth jobs until the fifth jobs, and after which you don't really see the increase or decrease that much. But it's very interesting that there is some settlement and stability of your career going on after fifth jobs. And recollecting my memory, actually, my fifth job is here, so it seems like pretty much stable. So career paths. So in the conclusion, we just went through that the nested skills is going up, and unnested skills, unlike unnested skills, regardless of ages, probably like with ages, like with the career path is going down in the unnested skills. There seems to be like diverging branches across different specialization and career paths. That is very much disconcerting. Wage premium. So we look at we go through these different paths. Different people go through different paths in the specialization trees. Then what's the wage consequences? We look at the responses of wages in to the amount of nested skill required by job, unnested skills required by job, and also controlled by general skills. And beta is located here. These are just the plots, and these are beta. And beta 1, you see the beta 1 and 2, you see the strike different, that beta 1, meaning the unnested, the more nested skill, positive one, more nested skill, higher wages. Beta 2, the more unnested skills you have, probably negative to your job, which is very much aligned with our common sense. Now, once we control them with the general skills, they actually go the opposite. So, so for unnested jobs, controlling maybe they start contributing to the education amount of education you do, that actually seems like unnested skills. Specialization is negative, but once you control it, it's positive. Another really interesting thing is that the amount of the contribution of the nested skills, once it's controlled, significantly go down, and probably like almost zero. So meaning that how important nested specialization is very important, but not as important as general skills, which has a huge implication in education system. Meaning the fundamental skills seems to be more important than, or equally important than, with the specialized skills. Maybe you can remember that when you are advancing your, nonlinear dynamics, and you realize, I should have done better in calculus. But if I was learning general relativity, then I realized, I should have studied harder in the algebra. So maybe like there is something going on. Like when you're advancing your skills, maybe it requires your fundamental skills accompanied with your increasing generalized skills. So that actually comes at almost the end of the talk, but I want to give you some idea, the example of, so we talked about the example of the individual specialization paths and the general structure we are observing. On one hand, every individual tried to find a way to get better job and better, like fulfilling your inclusive life and throughout the career. So you're specializing in like finding niches in the labor market, labor ecosystem. But in general, they come some together. We are probably embedded in this larger structure. And this structure will determine where you are going into. So finding out the structure and what's the implication of structure is very important to understand how where society is moving in. So, for example, the plus shows that what are the reachabilities. So I'm looking at the programming. So the first on the top, the network on the top. I'm asking that what's the chances, which skills is going to give me high probability to get to the programming? So meaning that let me just rephrasing. What are the skills that are dependent on the programming in our architect? So you see a lot of dark nodes, meaning that you need these kind of skills are needed to get to the programming. Negotiation, on the here, you have a high bundles over there, repairing less. So it's disconnected. So it's really hard to get to the repairing from those jobs and other places. So repairing the skill seems to be out far away. So that actually gives you some idea of why the individuals cannot access some certain skills and cannot change from one occupation to the other easier than some other occupations, some other mobilities. Some job transition is harder than the other job transitions, and determined by the structure. And the structure, of course, evolve over time. So this is 2 decades ago, and you have we constructed structure from the data of 2005, 2 decades ago. It seems like more cohesion and less unnested. Now 2020, you have a more deviated and branched out and shallow, and have some meaning about the labor disparity and the job segmentation and fragmentation of our society, and that was very unsettling. Again, the final slide is that, of course, it's not just that we are increasing complexity, and we have different devices always come in, and how do we keep up with that? At the end of the day, it's a specialization and working together, and that has huge consequences, as we just discussed, and the structure that emerges from this collaboration and specialization, and will give us some idea of where we are going and moving into. And finally, these are our collaborators, and Mo is here, the first author of the paper. The depth of the paper can be read in this archive version preprint. Thank you very much.
Okay, do we have any questions?
I have a few questions. Let me just start with a simple kind of clarification question. So was I right on a few slides back where you showed that the impact of unnested skills on wages was negative when you had the control for generality? Is there a way, I think you commented on this, but I didn't really get it. Why do you see,
I think this
with the control, it's positive?
Yeah, with the control is positive. So probably something like this. You see the ages increases, and usually age goes with wages as well, not necessarily one-to-one, but statistically, yes. And then you need a less unnested skills going down. Many may just give the association. Once you control this general skills associated with in the occupation that also have the unnested skills, a lot of unnested skills, then it goes to positive. Kara and Andy. Back.
Thanks so much, Hyejin. This is a great talk. I was wondering, how do you think about complexity and knowledge sphere, especially in regards to disruption in science?
It's interesting. Yes, disruption science is it's one thing we have really loaded term, and the discussion, what do we mean by disruption? Is it like we often these days conflate the disruption with the citation shadowing, but that's not really, I mean, it is a like good way to measure, but it's not really a reflection of what's really going on. So complexity, also again, it's like I acknowledge that I was using it very colloquially, but it's the case. Complexity can be defined many different things. It can be diversifications, number of different things. So generally, it's a term that like if we have a lot of different types in our class or in our group, then it's like more complex. And also, some people consider complexity as the way things are connected to others. So if the structure is more dense, connections in the concepts or the input and output is more complex. But there is no consensus definition of what it means by complexity. When we see it, we kind of know it, but we don't know what exactly it is. Andy.
We have a question from Zoom. What are your thoughts about specialization versus generalization and the resilience of societies? Specialization improves the productivity, but does it make society more resilient?
It's a good point. Generalist, the Ben Jones's paper actually suggests that we don't have generalists anymore. I mean, less generalists in the society as we move into more complex or in the advanced economy. But the specialized is so think about this like an extreme case. Imagine this room is comprised of all the specialized people. Everyone has his own niche. To understand each other is going to be really hard. And if we don't have any generalists, it's really hard to manage all these people together as a group. And also, it will actually make a. But if yes, but like the person was asking the resilience. The resilience has to be understood and specialized in each group. So if you are as a group, if we are specialized as a group, so everyone is a physicist here, is specialized, it's going to hit harder when the physicist is destroyed by ChatGPT. If we have a different specialized people, like individual specialized, and as a whole diversified, it's more resilient. That's the rule of thumb in terms of the resilient mechanism. But we have to think about when we think about the specialization, is it specialized in what, and what entity and what unit of analysis we are looking into.
Any other questions, Danny?
Another. Actually, I'll make this 2 comments. The first comment is there's an artist whose name I don't remember, but who tried to build a toaster from scratch.
Yeah, toaster project.
Toaster.
I was actually going to show it, and I decided not to, but it was very.
I haven't seen this about
There's a book about it, Toaster Project, guys. It's a really interesting book. It's a YouTube and TED Talk as well for the short version.
So the other question was on the occupations. So the growth in occupations and the occupations in this data set, who defines them? Are they defined by the surveyees, the people responding, or the
great
people creating the survey?
Another my passion, research passion, is about categorization. What do we mean by categorization? But because at the end of the day, guys, I'm just counting the types, and somebody has to define the types, and the types are defined by the different philosophy. Sometimes the things are categorized in terms of similarity. Sometimes things are categorized by functionality, even if they are not similar to each other. So, under what definition? But in our definition, in the current definition, we used the government-provided occupation classification, meaning that government needs to know how many occupation we need in the United States and what occupation needed what kind of job title. The categorization is some people say that categorization is a cluster concepts that help stakeholder to communicate with other stakeholder efficiently. So depending on but anyway, it's a longer answer than the short answer. Any questions? Any question about career advice?
All right. If we have no more questions, then we'll just give our speaker a round of applause.
Thank you very much.